Good afternoon.
Good afternoon.
All right, let's see. So Hannah, your camera's messed up. I can't even see. Is Joran even there? Oh, there's Joran. All right, so how about Chloe? Is Chloe there? Oh, there's Chloe. Okay, so we're at 100%. Awesome. All right, well, so today our plan is to cover 8.5, integration of rational functions by partial fraction decomposition, which is just as fun as it sounds. So before I jump into that, were there any issues with the test that I need to know about?
I was not able to complete my second attempt on both tests.
Okay. Okay, yeah, just let me know when you'd like to do your second attempt, okay?
Okay.
So that could be today, tomorrow, whenever, okay? Any weirdness? So yeah, because one of my trig classes, it's amazing how, like, in order to get the quiz to work out perfectly, to do it randomly, it's now gone from doing like 20 clicks perfect to like 100 clicks perfect. And so anyway, so I guess one click I did wrong was it actually, when they went to take it, it actually didn't open, instead of opening on February 26th, it didn't open till March 26th. So whoops. So anyway, those things are going to happen. So I just wanted to know if I was just an idiot once yesterday or if I was an idiot all day long. So apparently I was just an idiot once. So that makes me feel a little bit better. So anyway, okay, yeah, just let me know when you need that second attempt, okay, or on either quiz or both or whatever. Okay, so 8.5, let's go ahead and get started on that. Now, before I get started, I don't know. This is the kind of thing I always wonder if I should tell students or not. But but you'll figure it out soon enough. So I might as well just tell you. This section has the hardest algebra in the whole semester. Okay? It's this section right here. So it's not that it's the hardest, but it's a lot. Okay? Now, fortunately, the calculus is pretty easy. As a matter of fact, I would say the calculus that we do here is going to be, you've all done before. So the calculus is not the big deal, but the algebra is pretty exhausting. I'll put it that way at times. So, but we're going to try to get through it and practice as well as we can, okay? So it's integration of rational functions. So the rational functions, that means like a fraction, by partial fractions or partial fraction decomposition. Now, this is, partial fractions is something that some trig teachers skip. But I know you all had either me or Mr. Fritz. Is that right? Did anybody have anything?
I took it out of summer program at ASU.
Do you remember that topic? Partial fractions?
I don't know. Maybe if I see it, I'd remember.
Okay, so that's what I'm hoping, is that it'll come back to you, okay? Anyway, so Chloe, Skylar, did you guys have Mr. Fritz for trig, or did you have Mr. Burson, or who did you have?
I had Burson.
For trig,
Yeah. Well, college algebra, actually.
I had one of our teachers here.
Okay. Do you remember that topic?
A
Partial
little
fractions? A little bit? Okay.
Yeah.
All right. Well, all I'm hoping for is that you've been exposed to it. And then, because that way, your memory of it will come back. So it'll make it a little easier. Okay. So here we go. Let's start with this one. Okay. So this is the first blank on your paper. So what we're going to try to do is like we'll have some kind of polynomial here, which I have as a star. And then the denominator, if you can factor it to distinct linear factors, so linear factors that are different, then what we will do is break it up to a over one factor plus b over the second factor. Okay? Now, what that does is it allows us to integrate. So the idea is that maybe we can't integrate this. But if we could break it up into these two, then we can integrate them. Okay? Now you might say, well, where does all this come from? Okay? Well, first of all, you factor the denominator. And so the denominator factors to the x plus 1, x minus 3. So that's where those come from. Now, to get the 2 and the 3, well, that's going to be a lot of the work that we do today, is to get the 2 and the 3. And so I'm going to show you how to do that in just a minute. But I'm going to jump to the end so that you see the whole point of this. The whole point of it is that we can't integrate this. And none of our algebra tricks thus far would work. Can't do integration by parts. Can't do U substitution. It's not a trig substitution. But if we break it up to this and this, now these two we can integrate. And so if you kind of cover up the 2 or bring the 2 out front, then it's like the form du over u. And so let's just, okay. So that's actually one of the big pieces of information that we need to know here for this section. So I'm going to just put it up here to remind you that the integral of du over u is the natural log of the absolute value of u plus c. Okay? We're going to use that a lot. So it's very important that if you haven't learned that pattern, you learn it. Okay? Because when we get to this, that's like the finish line. And so we don't want to stumble over the finish line. Okay? Okay, so going back to here, see, the derivative of x plus 1 is just 1 dx. So if we bring the 2 in front, that's going to be 2 times the natural log of x plus 1 plus, bring the 3 in front, and it's the natural log of x minus 3 plus c. Okay? So this is where we start. This is where we finish. Okay? And so I'm going to teach you the middle part. Okay? It's kind of like that, I don't know if you've ever seen the Far Side cartoon, but one of my favorites is where it shows these scientists at the board and they're working this big complicated thing, and they start a ways, and then they have the end, and then in the middle it says, then a miracle occurs. And so this is where the miracle occurs to go from here to here, and then the end. So I'm going to teach you that middle part. Okay, so this is kind of the idea. So I want you to just watch this one, and then we're going to work through practice 1 together. Okay? But I just want you to see kind of what we're about here. So to get these two factors, it's the factors of this. So x squared minus 2x minus 3 factors to x plus 1, x minus 3. Okay? We put an a over one factor, a b over the other factor. All right, then to add these, to get this, what we would do is get a common denominator. So you'd multiply this first term, top and bottom, by x minus 3. And then the second term, we'd multiply top and bottom by the x plus 1. So that then we would have all the same denominator. All right, now to save time and space and lots of handwriting, I'm going to teach you another little algebra trick here. All right, and I don't know if you need to write this down or not because you'll remember it. The trick is this. If you have two fractions that are equal to each other and their denominators are the same, then you can ignore the denominators and just set the numerators equal to each other. So what does that have to do with this problem? Well, see, I've got all of these denominators that are going to be the same. So I don't need to write the denominators anymore. I don't need them to find a and b. So once I figured out what to multiply the a and the b by, so I'm going to multiply the a times x minus 3 and get ax minus 3a. I multiply the b by x plus 1 and I get bx plus b. Okay? So I'm not writing the denominators in anymore. All right, now I combine together the like terms. So ax and bx are like terms because they have an x. Negative 3a and b are also like terms because they don't have an x in them. So those are like our constants. Okay? All right, now, these coefficients of x, a plus b, they have to equal to whatever the coefficient of x is over here. So a plus b has to equal 5. So you write that down. A plus b is equal to 5. Then the two constants, negative 3a plus b, they have to equal to the constant negative 3. Okay, so now that's sort of phase 1 of the algebra. Now we go to the next phase of the algebra, which is solving this system of equations. Okay? Now, some of the systems of equations we will get will be 2 equations and 2 variables, 3 equations, 3 variables, 4 equations and 4 variables, so on. Okay? Now, when there are 2 equations and 2 variables like this, does anyone remember any of the methods you've learned to solve systems of equations from algebra? Okay, well, some of the methods that you might have learned are the method of addition or elimination, substitution, Kramer's rule, matrices, Gaussian elimination, and then in Math 152, the very last day of class, I teach you how to do it in the calculator. Okay, and so because I think that the harder the problems are, the better you want to use the calculator. I'm going to review how to do that in the calculator, hopefully today. But let's move on to this is a system of equations with 2 equations and 2 variables. A plus b is 5, negative 3a plus b is negative 3. So we're trying to solve what value for a and b would satisfy both of those equations. So the method I'm going to do is the addition method. So the addition method is where you want to add the 2 equations together and have one of the variables drop out. So like here I have b and negative b. Well, it wasn't negative b over here, but what I did is I actually multiplied through by negative 1, and then I'm going to add these 2 equations together, and the b's are going to drop out. So the b's drop out, so I get negative 4a is equal to negative 8. So that gives me a is 2. Then once I have 2, I do what's called back substitution. Plug in 2 for a there and solve for b, and I get b is 3. Okay? So that's where the 2 and the 3 come from. And then once I have the 2 and the 3, then that's when I plug in for the A and the B, the 2 and the 3, do the integrals and the calculus, and boom, it's done. Okay? So like I say, it has 20 steps, 19 of them are algebra. Okay? So that's kind of how that works. So let's do practice 1 together. Okay? Okay, whoops. Okay, so first, factor the denominator. All right, so Joey, what is the denominator factor to?
It factors to x plus 1 and x plus 2.
Great. Okay, so then you're going to break up your original integral to the integral of a over x plus 1 dx plus b over x plus 2 dx. So now we're going to use our algebra here to figure out what a and b are. Okay? So any questions on the setup so far? All right? So now you're going to try to get a common denominator. All right, so Aiden, what do I multiply this first one by? A over x plus 1, what do I multiply that by?
You multiply the top and bottom by x plus 2.
Good. And what will I multiply the second one by?
X plus 1.
X plus 1. Okay? So this one I'm going to multiply by x plus 2. This one I'm going to multiply by x plus 1. Okay? Now, at this step, see, you actually don't have to write in the denominators here because they're equal. And so we're going to just set the numerators equal to each other. So you can write them in if you want, so you just see what's going on, but you don't have to. All right? All right, so Skylar, when I distribute the A and the B, what do I get?
ax plus 2a plus bx plus b.
Equals 4x plus 1. Okay? Whoops. There we go. Okay? All right, now. Okay, so Aiden. So if we set the x terms together, what equation do we get? If we set the x terms equal to each other.
You get 4x. Wait, the x terms all on one side?
Yeah, no, you're saying it right. So 4x would be ax plus bx. So therefore 4 equals what?
A plus b.
A plus b. Okay? Everybody cool with that? All right. All right, so David, what's the other equation I get from the constants? So the terms without any x's.
2a plus b
Equals?
x 1
Equals 1. So this term over here that doesn't have any x is going to be equal to 2a plus b. So 2a plus b is equal to 1. All right, so now that's our system of equations. Any questions? All right, so now I want you to solve the system of equations. Any method you choose. Graphing was another one. I don't think I mentioned, but you learn how to do that. Graph systems in Algebra 1.
I have a question.
Yes, sir.
So when I first set it up, I had a over x plus 2 instead of x plus 1.
Oh, yeah. Okay, thank you so much for asking that. Okay, so what's going to happen is all your algebra will be different. But then the final answer, the calculus, will be the same.
Okay.
Okay? So just keep doing what you're doing. Ignore the board until the very, very end. All right, so Hannah, when you've got this system of equations solved, let us know.
I'm kind of stuck.
Okay, so what method did you try to use?
The one you used the or subtraction one or whatever.
Yeah, so they call that the addition or elimination. Actually, some teachers do call it subtraction. So, all right. So I actually am showing it two different ways. So let me go through the addition method. So you have what you want is your equations. You want one of the variables to drop out. So what I did is I multiplied this first equation by -1, so that that what would happen is I'd end up with a b, and then this would give me a -b, and when I add them up, they would drop out. Now, whatever you multiply by, you have to multiply all the way through. So notice it changes all the signs here. So then 2a minus a, or plus a -a, is just a. The b's drop out, and you get -3. So then you do your back substitution. So you plug in -3 for a. So 2 times -3 plus b equals 1. -6 plus b equals 1. So b equals 7. Now, it doesn't matter which variable you solve for first. You should get the same answer. Okay, now, another way to do it is by the substitution method. So with substitution, if you solve for one of the variables, so here I solved for a in this first equation, so a is 4 minus b, and then you substitute that in for a into the other equation. So 2 times 4 minus b plus b equals 1, 8 minus 2b plus b equals 1, 8 minus b equals 1, b is equal to 7. Back substitute. Let's see, where are we? A plus b, so a plus 7 equals 4, so a equals -3. So we got the same answer either way, either method. And like I said, there's tons more methods to use. All right? So, any questions on the system? So now I substitute in for a and b. And so I get the integral of -3 over x plus 1 dx plus the integral of 7 over x plus 2 dx.
Mr. Strong,
Yes.
does it matter which one we put over which one?
Well, it doesn't, but your algebra will be different, but then when you get to plugging in, you'll get the same you'll get the same one. See, like if your order was different and you chose your A and B opposite of mine, that's okay. All the algebra will be different, but then once you plug in, your integrals will be the same. Okay? So you should get the same answer.
I did get the algebra the same, but I put the -3 over x plus 2. Is it need to be this?
Yeah, that will matter. See, that will matter. See, I have the a over x plus 1. So at the beginning, do you have the a over x plus 2?
Yeah.
Okay.
Is that wrong?
Well, no, it's not wrong, but it's different than mine. So if you have the a over x plus 2, then you should have multiplied the a by x plus 1.
Oh.
And the b by x plus 2. You see what I'm saying? So your
Yeah.
algebra will be different, but not wrong.
Okay.
Okay? So, but for right now, just change your integral. Okay? And then don't worry about, and then just watch the algebra next time. Okay? All right, so now integrate these to get the final answer. And so, David, when you've got the final answer, let us know. Okay, this is supposed to be the step that you do in your head. So remember, you bring the -3 in front, and then it's going to be the natural log of the absolute value of x plus 1. Then you bring the 7 in front, and it'll be the natural log of the absolute value of x plus 2, and then slap the c at the end. Okay? All right, any questions? Okay? All right. All right, well, let's go on to the next one. Okay, so here, so part 2 is a slightly different variation, and it's when you have a repeated linear factor. See, if when you factor it, the denominator factors to like x plus 2 times x plus 2. Well, you can't have them both be over x plus 2. So what you do is you say, put a over x plus 2 and b over x plus 2 squared. So when the factor repeats, your first letter is over that factor to the first power, and the second letter is to the second power. Okay? All right, so let's look at this one. All right, so first of all, factor the denominator here. All right, so Skylar, what does this denominator here factor to?
X plus 1 times x plus 1.
Right. And so then the setup will be a over x plus 1 plus what? Plus what, Skylar? What will be the next part?
B over x plus 1 squared.
Good. Okay? So that's how you're going to break it up. All right, so Joran, what am I going to multiply a by to get the common denominator?
X plus 1.
And what do I multiply b by?
Nothing. As soon as you
Nothing.
multiply the first one, you get that.
Yes, very good. Excellent. Okay? So a is multiplied by x plus 1, b is multiplied by nothing, and set it equal to the 4x plus 1. All right, so now I want you to go through and work it out and solve that for a and b. All right, so Hannah, when you got a and b, let us know.
So I got a equals 4 and b equals -3.
All right. So a equals 4, b equals -3. Okay, any questions on that? Anyone not get that? Or lost on solving the systems?
I am still really confused on how you get your little
Okay. Okay, so did you get, let's go back up. Okay, so did you get this one?
Yeah.
Okay, so then you distribute the A, and so now you're going to set the x term. See, 4x is equal to, well, the only x over here is ax. So 4x is equal to ax, that means a is 4. And then the constant 1 is equal to a plus b. So if a plus b is 1 and a is 4, then that means b, you solve that for b and you get b is -3. Okay? Does that make sense? Okay.
Yes.
All right. So now you go ahead and plug in the a and the b up here and back into the integral. So you're going to get 4 over x plus 1, and we're going to take that integral. And b was -3 over x plus 1 squared, and we're going to do that integral. All right, so what's this first integral going to be?
Who did you call him, Mr. Strong?
Anybody.
Oh, it'll be 4 natural log of the absolute value of x plus 1.
Good. But see, we've got a problem here in that the derivative of this squared, see, is not up there. So we can't, this one, the second one is not going to be a natural log. Okay? Anyone have any idea of, anyone remember how we did this? How we did that kind of integral? We did it back in 8.1 and last semester too, I think. How do we integrate one like this?
Turn on. You let x plus 1 equals u. And
Yes, so very good. So u substitution. So let x plus 1 be u. Oops. And so then du is dx. And so then we're going to get -3. We'll pull that out front. And then we get u to the minus 2 du. And so when we integrate that, it's -3 u to the minus 1 divided by -1. And the negatives are going to cancel. So then it'll become plus 3 x plus 1 to the minus 1 plus c. So the first part was the natural log. The second part was u substitution. So that's good. So it helps us to remember how to do that.
Can you show all of the green work so we can follow along?
Oh, sure. So it's just the u substitution. Let u be what's in parentheses. Do the du, and then do the u substitution.
Thank you.
You're welcome. All right, any other questions on this one? Okay. All right, the next part. Integrating an improper fraction. If the fraction is improper, you must first use polynomial division to get a polynomial plus a proper fraction. Now, we did this back in 8.1, is we did polynomial division, but when we were done, the integral that we had left was easy. On this, we're going to do polynomial division first. Then when we're done, we have to do the partial fraction decomposition. Okay? So the algebra is just getting hairier. Okay? Not that being hairy is a bad thing. Okay. So when do we have to do this? When the exponent in the numerator is greater than the exponent in the denominator. Okay? Now, I know you've been doing polynomial division for a while, so let's see what you remember. So do polynomial division on this right here. So this is your dividend. So this is going to go under the quotient bar, the numerator. The denominator is your divisor. Okay, now, the two things you have to remember with polynomial division are, one, you have to have all your placeholders. And number two, your polynomials need to be in descending order. Okay? Now, with that, those little reminders, is there anyone that still has no clue as to where to start? Okay, so let me be quiet and let you try. So do the polynomial division here. All right, so Joey, when you've got it, or if you get stuck, let me know.
I'm stuck.
Okay. So first of all, when you set it up, you have to have all your placeholders here. So notice we don't have an x squared or an x. So we need to plug in a 0x squared and a 0x. So we need to have our placeholders. So this is the numerator is your dividend, so it goes underneath the quotient bar. And then outside we have our divisor, which is the denominator, x squared minus x minus 6. Okay? So now you look at the leading term, and you say, what times x squared is 4x cubed? So help me out on this, Joey. What times x squared would give me 4x cubed?
4x.
4x. So you write that up on top. Now, so then you divide through, or multiply through. So 4x times x squared is 4x cubed. 4x times negative x is negative 4x squared. And 4x times negative 6 is negative 24x. Now this is where you need another color pen, or a pen and a pencil, or whatever. A highlighter, something, because now you're going to change all the signs. And if you do it with the same color marker, you're going to get lost. I guarantee you, especially trying to look back. So you're going to change your signs, boom, boom, boom. So then this is going to go to 0. 0x squared plus 4x squared goes to 4x squared. 0x plus 24x is 24x. Bring down the 1. Okay, now you go through the same thing again. Look at the leading terms. So Joey, what times x squared would give you 4x squared?
Just 4.
Just 4. So we put a plus 4 on top and multiply through. 4 times x squared is 4x squared. 4 times negative x is negative 4x. 4 times negative 6 is negative 24. Change the signs. Boom, boom, boom. 4x squares cancel. 24x plus 4x is 28x. 1 plus 24 is 25. Now, x squared won't go into 28x, so that's the remainder. So we write the remainder over the divisor. And so now, this is going to be my new integral. The integral, so now it's going to be the integral of 4x plus 4, which those are easy to integrate. And then the remainder over the divisor, not so much. But we've at least broken it down some. But now, this is like what we've been doing. Except, I'm going to warn you, I'm pretty sure the A and the B are fractions or decimals on this. Okay? But let's continue on. Okay, so the integral of 4x is what?
Is it 4x squared divided by 2?
So 4x squared divided by 2, or 2x squared. And the integral of 4 is what?
4x.
4x. So we got to remember that to not get so lost in the rest of this that we forget the first two parts of the answer. Okay? All right, now. So now we're going to break this down. So x squared minus x minus 6. What does that factor to? Anybody?
X minus 3 and x plus 2.
Right. So we're going to have, and they're different, so we're going to have A over 1 and B over the other. So here I've integrated these first two. And now I'm breaking this one down. And so I'm going to have a over x minus 3 and b over x plus 2. Okay? All right, so now see if you can figure out what a and b are. And they're kind of ugly answers. So I'll just warn you, they're either decimals or fractions, however you want to do it. But it's actually okay. It's not going to make, it doesn't make the calculus any messier, that the fact that the algebra is messier. So I'm probably going to have you finish this one at home, and we'll start with it tomorrow. But let's just see, let's just go as far as we can get. So, Jordan, when you have the system of equations to solve, check with me and let's make sure that's right before you worry about solving it for A and B.
I got a plus b equals 28, and then 3a plus 2b equals 25.
Okay. Okay, so you had your factors opposite mine, right? You have the x plus 2 under here and the x minus 3 here. Is that right? And that's okay.
Yes.
Yeah, that's okay. So what that means is that your system is going to be different than mine, and that's okay. Okay? So don't change yours, okay? Go ahead and just solve it for A and B, okay? And then, so I want you to see if you can finish this problem before tomorrow. So solve the system, which if you have mine or Joran's, solve it for A and B, and then find the integrals. See if you can find the final, do the final answer, and we'll go over it tomorrow and see if you got it. Okay?
Yeah, speaking of tomorrow, Mr. Strong,
Yep.
I'm not going to be here. I'm doing a job shadow for senior project and stuff, so
Why don't you job shadow me? What the heck? Come on.
I should have
Wouldn't
done
you
that
love to
maybe.
teach calculus all day and trig and stuff? That sounds like super fun.
No,
I would even let you teach if you came in here.
No, sorry.
okay.
You
I'm
could
going
come
in
to